All right, welcome everybody to week 1, day 3. Um, we got some beautiful footage from the ISS going on in the background there. Today we're going to be talking about signed distance fields. Signed distance fields are actually really useful things when it comes to like graphics, and they've actually got a lot of uses besides just like ray tracing, ray marching applications. So, what Fridays are in this class, there's going to be a lot of lab time, and so what I don't want to see in lab time, especially in the online section, is people just like logging off and just like vanishing. So for this assignment in particular, I'm sort of waiving the normal plagiarism rules. I've got a cheat checker that gives me similarities between different students' code. It checks everybody's code against everybody else's code, and I've also got all the code from previous years in it. So for this one, you don't have to worry about it. Feel free to talk to each other and maybe not screenshot your entire solution because then people are just going to copy that. But if somebody's asking how do you make a new vector or something like that, feel free to just paste the code on there. It's fine. Don't worry too much about it. This is a 5-point assignment, not a 10-point assignment, so I'm going to be fairly lenient on the cheat aspect of things on this. So let's talk about an SDF. So the assignment is SDF1, which is a super dimensional fortress Macross or something. I don't know. But the way the thing works is you're going to start off by making a 2-dimensional map, 10 columns in this case, 10 rows. I'm going to add a asteroid at, I don't know, column 5, row 2. And then you enter -1, -1 when you're done. I could keep adding more if I wanted. I could put one down here if I wanted, but I'm just going to show you what it looks like with one asteroid. What it prints to the screen is at every point on the grid, it prints the number that is the distance to the nearest asteroid. Okay, so you can see the asteroid is printed out not as a 0, it's printed out as a asterisk. Everything that is 1 away from the asterisk is a 1. Everything that's 2 away is a 2. Everything that's 3 away is a 3. On the corners, you might notice some weirdness, like it jumps from 2 to 4. The reason for that is because we are using Pythagorean theorem, also known as hypot in C++, to compute the Euclidean distance between 2 points. We are not doing Manhattan distance. How many people here have never heard of Manhattan distance before? So Manhattan is, like downtown New York, kind of, right? And so when you travel through Manhattan, you can't just take a straight line between point A and point B because you're going to be running through skyscrapers or whatever, right? And so Manhattan distance means you have to travel along the blocks, right? And as it turns out, all 3 of these routes, the red, the blue, not the green's Euclidean, and the yellow, they're all the same distance. So it actually doesn't matter which route you take as long as you're not backtracking or going away from it. So basically, Manhattan distance you can compute by just differencing the rows, differencing the columns, and adding them together. It's kind of like on a triangle. If you just take the legs of the triangle and you just add those together, whereas Pythagoras is you take the hypotenuse. So the Pythagorean distance is the faster route, but if you're in a city block situation, you have to just travel east, 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 north, north, north. You can't take the shortcut because there's blocks in the way. So are we doing Manhattan distance? No. So you don't need to worry about it. But for those of you that were curious what Manhattan distance was, that's it. So you can see here that we're not doing Manhattan distance because it's actually doing, you guys all know the Pythagorean theorem, right? A squared plus b squared, quantity square rooted. In C++, there is a function called hypot, which, my face just vanished, which has nothing to do with 420 stuff. It's called hypot. And nope, not you, C++. And no, why are you just giving me these bad sites? I want to block this site, heck yeah. Boom, get out of here. C++.com, boom, get out of here. Geeks for Geeks, get out of here. All right. CPP reference, there we go. Number 1 C++ website of the world. Boom, hypot. Okay. And so what you do is you just pass in one leg, the length of one leg, the length of the other leg, and it gives you the hypotenuse. So you could write the Pythagorean theorem yourself. You're all smart people. You can do it. It's not that hard. But hypot is a little less typing. So if you want to save yourself a couple keystrokes, then hypot it up. Okay. So what should we talk about for this? Let me show you like a bigger example maybe. So we'll do like a 50 by 50 map with like one guy at like 12, 12, and one guy at like, I don't know, 17, 11, 17, 1. Why not? Okay. -1, -1 to enter, to end. So you can see the first number here is the column. It's the x direction. Normally, when we do computer science, we do the row first, then the column. But for this one, I wanted to do x, then y. I don't know. Top left corner is 0, 0 as normal in computer science. This is 0, 0 here. So if we go 17 to the right and 1 down, we end up right with this person right here. So that is column 17, row 1. And this one is at 12, 12. So what do we got here? So you can see these numbers, like they're 1 away, 2 away, 3 away, 4 away, 5 away, 6 away. But then once like we travel up a little bit further north, then we're 5 away, 4 away, 2 away, 1 away, because we're closer to another asteroid at that point. So the numbers that are printed to the screen are the distance to the nearest asteroid. Are you guys with me on this? So if you have a lot of asteroids, their sign distance fields will kind of blend together like this. And all you have to do in this assignment is really just make a vector of all the asteroids. And then for every point on the grid, do a hypot, Pythagorean theorem, to all of the asteroids and see which one has the shortest distance. There's more efficient algorithms than that are faster, but you don't need them. This assignment is purely a exercise of your ability to write a triply nested for loop, because you're going to say for every row, for every column, for every asteroid, get the distance from my point to the asteroid and pick the smallest one. So that's your homework. Any distance that is greater than 10, you draw a dot instead. The reason for that being, if you were to write a 10 here, it would screw up the formatting of the whole thing. So it also kind of looks cool. You know, like we could, say 40 by 40 and 10, 10, and 35, 35, 46, oops. 40, 40, 10, 10, 35, 35. And it kind of creates these cool looking like things. So kind of looks nice. I don't know. Any place where there's an asteroid, you draw an asterisk instead of 0. Anything greater than 9, you draw a dot instead. Okay. So let's take a look at the starting code that I've given you. I haven't given you a lot of starting code, but do a little bit here. So it shows you how to use my read library. You don't have to use my read library if you don't want to. You can use CN. There's absolutely no difference in it. This is how you make a two-dimensional vector of integers. And so you can access it like this. So you can say, this is row 5, column 10. This will access the two-dimensional data structure, two-dimensional array, two-dimensional vector, whatever you want to call it, two-dimensional matrix. It accesses the value at 5 down, 10 across. And you can also set values the same way, map.at 5.at 20 is equal to 42. That'll set the value of 42 at row 5, column 20. So that's how you make a two-dimensional data structure in C++. The other thing that you guys should probably do is make some sort of struct for an asteroid. Maybe. What kinds of things describe an asteroid? So this is, philosophically speaking, what attributes does an asteroid have in this program? It's got a position, it's got a size, what else? Mass? We can animate the asteroids and have their mass do elastic and inelastic collisions. I like your thinking, but yeah, for this assignment we don't need mass, bigness, radius. Now all of our asteroids just have a radius of 1 grid point. Name them. Yeah, you can name it like Haley Bop. You know I don't know if you guys. Remember this one. So it was in 1997. The Haley Bop caused this whole cult to like think it was a UFO and off themselves. Yeah, charisma, gravitational spin. Yeah, my boss actually did the website for the realtor who sold the house in I think it was Carlsbad. It's a really nice house, by the way. They had where they all off themselves, and so he put together the website to sell the very nice property where they off themselves. So cultability, yeah. Yeah, okay. So I guess just position. I can't really think of anything else. We can have like integer column and integer row. And if we wanted to be good citizens, we'd initialize these values to 0. I think that's pretty good. There's only one option that I might give you guys, and that is to put the column into one struct and the row into another struct. Do you know what it's called when you have half an asteroid? It's called a hemorrhoid. So. Dad jokes indeed. I'm wearing the shirt for it, you know. Daddy, why do you always make dad jokes? Just answer your own question. All right. Yeah, no, it should look like that. It should look like that. Okay. So, that's probably enough for you guys to go on. So think about how you're going to approach this. There's obviously an input phase. You're going to need to do error checking. You can either do the error checking right now first as you're doing it, or you can add it in later. It's up to you. But you're going to like do an input phase where you first read in the rows and columns and make a 2D map. That's done for you right here. You're then going to input a number of asteroids. And do you guys know how to make a vector of asteroids? Something like a vector of asteroids. Yeah, just like that. And then you can like make a new asteroid and push back on the asteroid vector. And basically, when the input phase is over, you're going to basically loop over every column, every row. And then at that point, at that column, that row, you're going to hypot to each of the asteroids and output whichever distance is the smallest. And you're done. That's the assignment. You guys got till Wednesday to do it. You're going to have 2 hours to work on it today. If you have any questions, just post it on the chat channel. I'm going to be here. I don't know if there's any other TAs right now. Bedencourt's here. And we will, and feel free to answer each other's questions. Like I said, don't post your entire solution, because that actually hurts students that don't know what they're doing, because then they just copy and paste it and they don't learn. But like for like 1 or 2 lines of code, copy and paste it, no problem. And then I guess that's it for our stream right now. So I'm just gonna yeah, I'm just gonna end it here. And if there's anything that I can think of like later on, then I'll resume the stream and upload it later. Okay, have fun. Don't just quit. I want you guys working, you know, and doing this, because this will give you a good leg up on the assignment, so you're not waiting to the last minute. Okay, so I'm going to pause the stream now, and if there's any important questions, then we can talk about that by unpausing the stream. All right, so that's it for the class today. Got some good questions there, but nothing I think needs to go onto the recording here. Basically, This is developing your proficiency with 2D arrays, 2D vectors, and it should kind of expand your mind a little bit, hurt your mind a little bit, because you've got to do a triply nested for loop to do it, making a vector of a class. So it's a good exercise. Again, feel free to ask questions 24/7 on Discord, and I will see you guys on Wednesday because there's no class on Monday. Peace.